50 as 25 and 2. So whenever we go in, it's kind of like you're taking the square root of each of those factors. So I'm going in and taking the square root of 25 and the square root of 2. What is the square root of 25? 5. So my answer is 5 square roots of 2. We are just simplifying radicals. That's all we're doing. Okay, what is a perfect square that is a factor of 48? 16 and 3. 16, 3. Okay, I'm going to go in. I'm going to take the square root of 16. I'm going to take the square root of 3. What is the square root of 16? 4. Now, the one thing about this is this number had a 2 at the very front. If you have a number on the outside, you will multiply it with whatever gets pulled from the radical. So 2 times 4 is going to give me 8 square roots of 3.
So we just have to multiply like the number
that was already there with whatever number you're pulling out of the radical.
Okay, got it.
It's just that.
Just that.
No trick.
Not yet. That's not new. That is the stuff we've already done. Okay, let's go in. The next part, because this is not the new stuff. This is the stuff that you should have known coming into today's lesson. Whenever we go in and we take the x squared plus 1 equals 0. X squared plus 1 equals 0. If I wanted to solve that, what do? Subtract 1. So I'm going to go in, I'm going to subtract 1 from the left, subtract 1 from the right. I'm going to get x squared equals negative 1. Again, I'm trying to solve. What do I do next?
Square root.
Square root. So I'm going to take the square root of the left, I'm going to take the square root of the right. And I'm going to get x equals the square root of negative 1. Now, one thing that happens, and one of the things that we discussed when we were doing the parent function for a square root, is you cannot take the square root of a negative number. And we said that eventually we get to a point where we could. So whenever you see x equals the square root of negative 1, that is creating a solution that has an imaginary number in it. Now, before you freak out and you're like, what is an imaginary number? It's basically going in and saying that that has a square root of a negative number. You can still go through and you can still do all of your regular solving. It's just now, instead of having a negative, it gets represented by an I. So the imaginary unit I is defined to be anytime you take I squared, that's negative 1, or you can also replace I with the square root of negative 1. So the only thing that you really have to know is every time you see a negative in the radical, there is going to be an I in your answer. So it's not going to change anything that we've done. If I wanted to go in and look at the square root of negative 16, I can split this into negative 1 and 16. So I can do the square root of negative 1, the square root of 16. And what did we say the square root of 16 is? 4. And so the square root of negative 1 is just I. Now, I is going to kind of, it's not really a variable like x is, but we always write it similar to what we do for x. So when you write your final answer, you write your I second. So my answer is going to be 4i. So that is the only extra thing that you're doing. My front table, y'all need to stop talking.
Do we always have to make the I lowercase, or does
Yes.
it not matter?
Always make it lowercase.
And it always goes behind the number.
Behind the number. Okay, so let's look at negative 27. I see two things. Kind of three. I like to do the negative one last, just as so I know to put it at the very end. Is there a factor of 27 that is a perfect square?
No.
9. So we can do 9 and 3. And so I could go in, take the square root of 9, take the square root of 3, take the square root of negative 1. And so with that, the square root of 9 is going to give me 3. The square root of negative 1 is going to give me I. And then the square root of 3, you can't do anything with. So you leave it alone. Again, nothing from simplifying radicals to this is different.
I thought it had to be after.
So it goes kind of like where the x would go. You don't put it at the end of the radical because a lot of the time people think it's under the radical when it's not.
I see.
So I is just the imaginary number.
Just the imaginary number.
Why is this?
So is it like X?
Wait, what is this? What is this?
Hold on.
Why is
Ma-
there like 3 numbers there too?
What do you mean, why is there 3 numbers?
Why is there an imaginary number?
Because negative 1 is the factor that we have to pull out. Because there's 3 factors.
Oh, because it can't be negative?
Because it cannot be negative underneath the radical.
So -1 always has to be added.
If there is a negative number in the radical, yes.
Oh, so you're just like subtracting negative 1?
You're multiplying by negative 1.
Negative, you always have to.
You're always going to have an I.
What would this like actually be used for? Like with imaginary numbers?
It's a big part of engineering. And when you get into pre-cal and all of that, you will do a lot with imaginary numbers.
Well,
If you want to be in engineering in any STEM field, you will use imaginary numbers. Unfortunately so.
how are you going to engineer something if you don't even know what the actual number is? Just some random.
Yeah.
It's a representation of taking the square root of something. It's still a solution. It's just not something that's graphed on the XY plane. So it gets graphed on a different plane than just XY. Okay, let's keep going. The longer we take, again, the less time you have. Okay, I'm looking at negative 500. Yes, I wrote the second example as 3. You don't have to write it as 3. What is a factor of 500 that is a perfect square? 100. So I can also split this. Instead of doing 105 and negative 1, I can do negative 105. The only thing that really matters is the fact that you know that a negative number, when I come in and I take the square root of it, it is going to produce an I to represent the fact that it is a square root of a negative number. So what is the square root of 100? 10. So I'm going to have 10I square roots of 5.
How come it becomes positive?
The I represents a negative.
Okay.
That's
Wait,
why.
So,
So why is there 2 numbers?
so
Yes.
anytime we have a negative, the I just has to.
Has to be there.
Why did we use 3 numbers for the second?
I said you can do it either way. You could have wrote negative 9 times 3 and gotten the same thing. So how it's the same thing, just written 2 different ways. Okay, that is one part of today. Let's go to the next part. Now, the power of I kind of changes a little bit. If I take anything to the power of 1, what do I get? If I take anything to the power of 1, what do I get?
Itself.
Itself. So I to the 1 is I. Okay, if I take I squared, we just talked about how I squared is equal to negative 1. Now the reason being, I'm going to give you a little reasoning behind this. If I go in, we said I is equal to the square root of negative 1. If I take the square root of negative 1 times the square root of negative 1, they cancel each other out, and we just get negative 1. That's why. Okay, if I take I cubed, there is too much side conversation going on. I'm not going to talk over you. I have filled in notes that I could post that you can learn this on your own. So I highly suggest you pay attention because you have to know this information when you come back from Thanksgiving break because you will be taking a test over this. You have to know it. Okay, so we have I and negative 1. If I have I cubed, one of the things that we've learned in Algebra 1 is that if I want to make something become cubed, I can also think of this as I times I squared because I could go in and add those 2 exponents together. And we've already said what I and I squared are. It's I and negative 1. So what is I times negative 1. It's not
negative 1.
what do you
Negative I.
negative I. There we go.
Wait, that actually makes sense.
It's negative 1 times I.
No, I'm so serious.
Negative 1 times I. What's negative 1 times 2?
2.
Negative 2. What's negative 1 times 3?
I guess.
So are all of this just gonna be negative I?
No.
Bro.
Only one of them has been negative I.
Wait, okay, so the
Only one of them
the
can be
I
negative.
you said it represents a negative.
Wait, yeah, what's the negative? So it's positive.
It's a negative 1 times the I.
Well, I guess.
The negative 1 is separately.
No, I already represents a negative 3.
But if, okay, we're going to go back to this. Hold on, before we go any further. Because we're going to be confused either way. Okay, breaking this down. We said I1 is I, correct? I1 is I. I1 is I. Okay, I2 is I1 times I1, correct?
Yes.
Yes. So if I go in, this is, and what does I1 represent? It represents the square root of negative 1.
Wait, yes. So if it's
Hold on. No. If I have square root of negative 1 is I. This means it's the square root of negative 1 times the square root of negative 1. Correct?
Yes.
Correct. Right? Square root of negative 1 times square root of negative 1. If you have two of the same thing, you can write it as the square root of negative 1 squared. Right? Because is it not the same thing times the same thing?
That is true.
That is true. What happens to a square root and a squared?
They cancel out.
They cancel out. I squared is equal to negative 1. Are we with me so far?
Yes.
Yes. Okay, so that's the I squared. Now, I cubed. I cubed. Technically, we can go in and do I, whatever. But I'm going to take it as I squared times I to the first. Because what happens when we multiply, what do we do to the exponents? You add them together, right? So 2 plus 1 is 3. Is this line equal to each other so far?
Yes.
Yes. So we just said I squared is negative 1. And we just said I is I. Negative 1 times I is negative I. We are here.
To break it down.
It's just breaking it down for my people who have not seen it yet. I to the fourth.
None of us have seen it.
We've got people who understand what's going on.
I kind of get it, but
I to the fourth. How can I write I to the fourth?
I squared times I squared.
I squared times I squared. What is I squared equal to? Negative 1. So I'm going to have negative 1 times negative 1.
that makes sense.
What's negative 1 times negative 1? 1. There we go. I'll put it at the end.
I guess.
1.
Did you update my
No. Okay. Now, I will wait for your side conversations to finish. We will take the whole 90 minutes if it takes us the whole 90 minutes to get there. I got nothing but time.
Just 90 minutes.
I can take this whole 90 minutes. Okay, what you need to know is that these are the 4 possibilities for what your answer could look like. These are the only 4 answers you could have. Now, what happens is the pattern continues. It goes from the starting point of it being I, it goes to negative 1, it goes to negative I, and then it goes to positive 1, and then it starts over again. So the easiest way when you have numbers that aren't like immediately one after the other is to go in and divide your exponent by 4. Because it's a cycle of 4. And so what we're going to do, when you divide by 4, you're going to look at your remainders. And if you have a remainder of 1, it's going to be I. If you have a remainder of 2, it's going to be negative 1. If you have a remainder of 3, it's going to be negative I. And if you have a remainder of 0, because it's a cycle of 4, it's going to be 1. Technically, it's like a remainder of 4, but it's really 0 because it's going to divide evenly. Okay, so kind of taking that idea. If I take 5 and I divide it by 4, what is my remainder?
1.
1. So if I have a remainder of 1, it's I.
Wait, how did you know you had a remainder?
Because it's not an even number.
If I divide 5 by 4, what is left
You're
over?
dividing it by 4.
Wait, you
Divide by 4.
You divide all of them by 4?
All of the exponents by 4.
I divided by 4.
If I divide 6 by 4, what is the remainder? 2. If the remainder is 2, it's negative 1.
You divide 5 by 4. And you take away the 4 from the 5. What do you have? No, it's not. So if I have 5 and I divide it by 4, how many do I have? You have a remainder of 9.
Wait, and then I7 is going to be negative.
One is the remainder.
I8.
Bro, Mark.
Yes, Leah.
Okay, so you're wrong. You get 1. So why does it not?
Huh?
So why does it not?
Because I said if you have a remainder 1, it's I.
Wait, why is it 4?
Because it's a cycle of 4.
Wait, Mark, you're actually right.
Wait, I20 is
1.
Remainder.
I just about 20 is
Hold on. Let's get through the rest. If I take 7 and I divide it by 4, what is the remainder? 3. So that means it's negative I. If I take 8 and I divide it by 4, what is the remainder? 0. So it's a 1. If I take 20 and I divide it by 4, do I have a remainder? No. So it is a 1. Okay. Now, a lot of this is going to depend on you knowing how to divide. That's something we got to work on. If you fail to know what it is, you can always go in and divide 4 into 34. What's the biggest multiple that's going to go into 34?
6.
8.
8? 8 times 4, yeah. 8 times 4, 32. We subtract. What's my remainder? 2. So it's going to be equal to negative 1. So it's just division. Just division. 4 goes into 49. 1, 4, 0, 9. How many times does 4 go into 9? 2. 8 with a remainder of 1. Remainder of 1 is going to be I.
Oh, that makes sense.
So you are literally just dividing by 4, seeing what your remainder is, and then going in and matching it to the correct I term.
Wait, can you go the one with the I is 20? Because how do we get 1 from dividing into 25?
Because it divides with no remainder. 20 divided by 4 is just 5.
Okay, yeah, you're right.
So no remainder.
No, the remainder.
No, that's your quotient, yes.
And that's why it's 1.
It's literally on the thing.
Okay. When I go in for 55, what is my remainder for 55? What did you say, Jaden?
It's 3.
Is it 4, 55? 1, 4, 15. 4 goes into 15 3 times, 12? 3. Remainder 3. What does remainder 3 tell me it is? Negative I. You will have to know to divide by 4. Now, here's a little thing, because you're going to ask me this when we come back from Thanksgiving break. This chart is not on your test. you have to know this chart. If you do not know this chart, you can always do what we did,
Wait, miss, that's not
and you can go in and you can break it down and figure out which one is which. So if it's in your best interest to just memorize it, know what they are.
I'm saying
It's a pattern. You just have to know the first 4. That's all you got to know.
Oh, that's valid.
Okay, are we ready to go on? Okay, now, simplifying. A lot of the regular multiplying rules are still going to apply. So whenever you go in, you're going to multiply the numbers with the numbers. The i's you just kind of treat like x's. If you had x times x, what would you say that's equal to? X squared. So if you have I times I, you're just going to think of that as I squared. And the only thing you have to remember is if you see I squared, it's equal to -1. In our answers, we are going to ask that you simplify any I squareds that you see. So when I look at my first problem, number times number, what's the -5 times 3? -15. And the I times the I is I squared. And what did we just say I squared is equal to? -1. So -15 times -1. What does that give me as my final answer? +15. I multiplied.
So you see, what's 5? What's -5 times 3?
Okay, going on. I have the square root of -20. What is a factor of 20 that is a perfect square? 4. So I'm going to write this as -4 times 5 because I have to take that negative out of the radical, no matter what. Now, when I go in, I'm going to have my I from the very beginning there. What is the square root of -4? 2 what? 2i. Square roots of 5. And then what is a factor of 12 that is a perfect square? Another 4. So -4 and 3. So times the same thing is going to come out because I'm taking the square root of -4 and the square root of 3. I'm going to end up with 2i square roots of 3. So whenever you have pieces like this, if you have a radical and you have numbers in front, you're going to treat the numbers in front all together. They're all going to get multiplied together. And then your radical pieces are going to get multiplied together.
So we're just combining like terms now?
We're not going to combine. We're going to multiply.
Multiply like.
Multiply like terms.
So it's 4i.
Gabe, quit talking across my room. Nala,
I cubed is -4.
I was laughing at that.
I will ask you to leave the room if you cannot keep it together. Okay, my I terms. I have a 2 and I have 3 i's. I times I times I is what? Let's start with the first step. What would the first step be? It would be I to the power of 3. Because I times I times I. Square root. If you have a radical and you're multiplying it, you multiply the numbers inside. 5 times 3.
I have a question.
Yes.
Do we multiply the 2's together? No.
Oh, yes. Sorry. Thank you, Layton. 4i cubed.
4i cubed.
I'm going to get to the I cube part in just a second. I haven't done that one yet. So when I go in and I look at my table, what did we say I cubed was equal to? -I. So when I simplify this, this is going to be -4i square roots of 15. Because I cubed is equal to -I. All of this is, again, dependent on you knowing those 4 rules. Okay, for parentheses, we are going to distribute like normal. We're going to distribute. What's negative 4 times 3? Negative 12. What's I times I? I squared. And then the other one is what's negative 4 times negative 2? Positive 8i. And what did we say x squared was, or I squared was equal to? Negative 1. So negative 12 times negative 1 plus 8i. So we're going to have 12 plus 8i. You will not combine, so the part in front, the 12, is a real number. No imaginary numbers attached to it. The 8i is an imaginary number. You do not combine them together. Do not make this 20i. You cannot do that. Think of it like doing 2 plus 3x. You don't make that 5x. So you will not do that for imaginary numbers. Let's go to the back. We haven't even got to the hard stuff. That took 30 minutes, 40 minutes. I told you I got all 90 minutes. I got nothing but time. I don't have to teach tomorrow, so.
Why don't you have to teach tomorrow?
Because I've already taught.
You don't have statistics?
I have all statistics on.
Did you get my mom's email?
I did get your mom's email.
Did you get my mom's email?
I did get your mom's email, too.
It's not true, it's a lie.
I mean, you're here, so.
Exactly. But no, what she said I did was a lie.
Okay, so a complex number is any number that can be written in the form a plus bi, where a is the real part, bi is the imaginary part. So just what I did, the last example I used had a real part and an imaginary part. You cannot combine them together. So simplifying these expressions, pretty easy. All you have to do is look at the problem. Look at the parts that are real numbers. Look at the parts that are imaginary numbers. Those are the only 2 things that you can combine with each other. So what is 5 plus 2? 7. Now, for combining the imaginaries, you're just dealing with the coefficients. What's negative 7 plus 4? Negative 3. So I'm going to have negative 3i. That's it.
That's the answer?
That's the answer. Huh?
Wait, this is the hard eyes. Those don't like combine with like.
It's probably the
Exponent.
I don't think so.
There's no exponents if we're not multiplying,
Oh, okay.
because we're not multiplying. We're just combining terms.
Okay, but that's so like if you were to multiply things.
Then that would be I squared.
4 minus 2 is
Okay, looking at the second example, what is something I have to be careful about? The negative. That negative is going to distribute to both terms that follow. 4 minus 8i minus 3 plus 6i. If you see a negative subtraction, you have to make sure that you're distributing that sign throughout. Otherwise, you're not going to get the right answer. I'm going to have my real parts are going to get combined together. My imaginary parts are going to get combined together. Again, we're not multiplying, so the i's are not changing. They're just getting combined. So what is 4 minus 3? 1. And then what's negative 8 plus 6?
Negative 2.
Negative 2. So that's going to be my negative 2i. That is the answer.
I thought you said this was hard.
We're getting there. Okay, I want you to try the third example. Try it, see what you get. Try the third one and see what you get.
Do you think that you guys would?
You have a part of it right, that's a double distribution. You'll get 5 plus 4.
Wait.
Give me like. I'm really scared of this.
It's like, make sure before you get in a relationship, because what if it's like one-sided and then you don't feel like they're gonna
What do you do? What do you do? Let me see. What do you do?
What'd you get? What'd you get?
5 plus 4i.
I got.
Dude, I didn't even know how that happened. No, I just threw it and it landed in there, bro. I seriously. I seriously. I was like,
I 5 plus 4i. Perfect. If I go in, I saw most people with the right answer. We should be getting 5 plus 4i.
Oh, because it's the negative in the middle.
The negative has to distribute. Okay, let's do the last part.
wait, so the negative makes the signs flip on the second side?
Correct.
Okay.
Second part is multiplication. How do you think I do this? Double distribute. Thank you, Isabella. We are going to distribute to every single term. Okay. What is 2 times 9? 18. What is 2 times negative 3i? Negative 6i. What is 4i times 9? 36i. And then what is 4i times negative 3i? Negative 12i squared. There we go. Now, before I do anything else, what is I squared equal to? Negative 1. So I'm going to go in. I'm going to change this to be negative 1. So I'm going to have 18 minus 6i plus 36i plus 12. And at this point, it turns into a problem where you combine the real parts together and you combine your imaginary parts together. So what is my real total? What's 18 plus 12?
30.
30. And what is my imaginary?
30i.
Plus 30i. Huh? It's not that hard. Well, we spent 40 minutes understanding imaginary numbers.
That was hard. That was hard.
Wait,
This isn't hard. That
Did
was.
you just
I feel like
get
this
rid of
one's
the negative 1?
Yeah.
Just like not want it.
Negative 1 times negative 12 is 12. I just multiplied them.
Oh.
Okay, I want you to try the second one. 4 minus 4i, or 8i. 4 minus 8i. Try it on your own. Let's see what you get.
That's what I did. I don't know that.
Come on, Matthew. Try it. I even started it.
16.
Come on.
64. Bro, you does
Be a negative 1. And then that's going to change your final answer. Yep, it's going to add in.
8 times 4 is 32, right?
Wait.
So negative.
What's 8 times 64i squared? Can we do negative? Okay.
What is 8 times your R?
Wait, how many 32 eyes are there going to be?
1.
I'm doing the
Oh, because yeah.
Anything but. That was funny, right?
So this right so far?
Right, because then it's like that.
Can you check mine now?
We could do
But it's going to be negative.
Yeah, I forgot about the next one. What did I do next? Oh, I turned this 64.
Oh, well, it was in fact not right. So then this.
Wait, this Martinez.
Oh,
great.
what's the negative 32 eyes? Take this to like.
So would this just cancel out each other? So this would just be 0?
Is it a plus and a minus?
Am I so stupid?
That's still not gonna be right.
So it's negative. No, all you gotta do is square it.
What's negative 32?
Wait, I must have figured it out. Personally, I finish it.
So what do you think? I squared.
Oh, wait, no.
No, wait. How did you get Oh, yeah.
I don't know how the table is not here.
Check your answer. See if what you got matches with what I got.
We will ask you to put the middle part.
How did I actually get negative 48?
How did I get negative 48? What's 16 minus 64? Negative 48.
Does the I always have to be second?
Yes.
Yes.
What's I squared? What is I squared? Negative 1. What's negative 1 times positive 64? Negative 64. Because of the chart, it goes full circle. Okay, I want you, underneath the radical, I want you to do the multiplication. Try doing the 3 minus 6i, the 3 plus 6i. Don't worry about the radical yet.
You double distribute that, right?
Double distribute that.
Oh, wait, did I get this?
What happened to your square root? Keep the square root.
You're close. You have the right to do it.
Oh, wait. I don't know.
I got a lot.
I'm off.
Mark, just show me what that is.
Can we not talk about that?
Wait, we just did, I'll do the whole thing and then 36.
3 times 3 is 9. 3 times 6 is 16. Negative 6 is 9.
Hey, Jack and Jay.
What's negative 6 is? Wait, what's that nice stuff?
Good, you're close. I need you to just boil the inside first.
Wait, Miss Sargent.
Why are you laughing?
Well, you're doing,
I square J.
it's gone, it's gone.
Is it just 45?
Oh, it's
Mark, what do you want for your birthday? This Mark.
and then 45.
Okay, you should be where I am. What did we say I squared is? Negative 1. What happens to negative 18i and positive 18i? They cancel. Square root 9 plus 36. Okay, what's 9 plus 36? 45. What do you think I have to do to this radical at the end? Simplify it. What is a factor of 45 that is a perfect square? 9 and 5. Square root of 9, square root of 5. What is the square root of 9? 3. 3 square roots of 5.